Hey guys, welcome to ANS Solver. Today we'll be doing the concept of parametric equations, which is a subtopic in the chapter of differentiation. Okay, so basically this concept is really simple. We'll be doing this via an example. Okay, let's say in parametric equations they properly specify. Okay, they specify that you know that these are parametric equations so that you don't need to basically identify. Okay, it's really simple to identify. So basically you will get an equation in terms of x, an equation in terms of y, and there will be a common variable. Let's say my x will be something like 3t plus sine 2t, correct, and my y will be equal to 4 plus 2 cos 2t. So as you can see, x and y are equal to something in terms of t, correct? And now basically the question will be, we need to find, okay, the dy by dx. Okay, now the basic concept which you need to know here is that dy by dx is equal to your dy divided by dt divided by dx by dt, correct? You might be confused that how is it derived. Basically I know I can write this as dy by dt multiplied by dt by dx, correct, because it reciprocates if the sign changes from division to multiplication. And here, as the dt cancels, you get a dy by dx, correct, the same thing as it is. Okay, so this concept is really important to know. So the first thing you do is you calculate your dy by dt, which is basically the differentiation of y equals to 4 plus 2 cos 2t. So first the differentiation of 4, the differentiation of 4 is 0, correct? Then you have the differentiation of cos. The differentiation of cos is minus sign. So I can write this as plus 2 into minus sine 2t, which will be multiplied by the differentiation of 2t because of the chain rule, which is 2. So I can simply write this as 2 multiplied by 2, which is 4, correct, and the minus sign, which will give me minus 4 sine 2t, correct. Now I can simply calculate my dx by dt, which is basically the differentiation, correct, of the x which I have here. So the differentiation of 3t, okay, is 3. So I simply write 3 here. And the differentiation of sine here, okay, is cos. So I write first cos 2t, but because of the chain rule, this is multiplied by the differentiation of 2t, which is 2. So I can simply write this as 3 plus 2 cos 2t. Now I can write my dy by dx, okay, basically as I know dy by dt divided by, I'll just write this as division so that you're 100% sure. I know this is dy by dt, correct, divided by dx by dt. So I can simply write this, my dy by dx, as I know my dy by dt is minus 4 sine 2t divided by my dx by dt is 3 plus 2 cos 2t, correct. So this is basically the final dy by dx. So let's go over the process again. First, I know my question. They always specify that there are parametric equations. Okay, it's always specified. So you will basically get x and y in terms of some variable. It can either be t, theta, anything. Okay. So first you calculate, okay, you know that your dy by dx is dy by dt divided by dx by dt. So first you calculate dy by dt where you differentiate the y function, and then your dx by dt where you differentiate the x function. Then you simply do, to calculate your dy by dx, you do dy by dt divided by dx by dt. And whatever equation you get is basically your dy by dx. Correct? It's a simple process. Now we can move on to a past paper question so that we are sure of how, to simply implement the process. So this example is basically a 2019 October-November paper 22 example. Okay, so now basically here the parametric equations, see here they are specified properly, that the parametric equations of a curve are x equals to 3 sine 2 theta and y equals to 1 plus 2 tan 2 theta, where theta lies in between 0 to 1 over 4 pi. We need the exact gradient of the curve at the point where theta equals to 1 over 6 pi. So first, I know I need my dy by dx because of the gradient. My dy by dx is basically dy by dt divided by my dx by dt. So I can calculate my dy by dt, okay, which is basically the differentiation of y here. So the differentiation of 1 is basically 0 plus the differentiation of tan. What is the differentiation of tan? It's simply sec square. So I can write this as 2 into sec square 2 theta. But this will be multiplied by the differentiation of 2 theta, which is 2. So I can write this as 2 into 2, which is 4. So I can write this as 4 sec square 2 theta. Correct? This is what I have. Now in the same way, I have my dx by dt, which is the differentiation of sine first. The differentiation of sine is basically cos. So I can write this as 3 cos 2 theta multiplied by the differentiation of 2 theta, which is 2. Now I can do 3 into 2, which is 6. So I can write this as 6 cos 2 theta. So now I can write my dy by dx basically as dy by dt, correct, which is 4 sec square 2 theta divided by dx by dt, which is 6 cos 2 theta. Correct? I know I can write this as dy by dx, which is equal to, I know sec square 2 theta can be written as 1 over cos square 2 theta. So I can write this as 4 divided by 6 cos 2 theta multiplied by, because I know here that sec square 2 theta can be written as 1 over cos square 2 theta. I can simply multiply cos square 2 theta here. So I basically get my dy by dx as 4 divided by, I get 6 into cos 2 theta into cos square 2 theta. So I get cos cube 2 theta. Now I need the dy by dx. I have the value of theta as 1 over 6 pi. So I can write my dy by dx as 4 divided by 6 cos cube 2 into theta. My theta is 1 over 6 pi. Correct? Now on the radian mode, when I write this on the calc, correct, I get my answer basically as, okay, I get my answer as 16 over 3. Correct? So this is basically the gradient. Correct? A very simple process to follow. Now the second part, we need to find the value of theta at the point where the gradient of the curve is equal to 2. That means my dy by dx is equal to 2. Okay? I need to give the answer to 3 significant figures. So I know my dy by dx is basically, okay, we need to write the function which we have as 4 over 6 cos cube 2x, or sorry, 2 theta, my bad. Correct? This was my function. Now I know this is equal to 2, so I get 2 equals to 4 over 6 cos cube 2 theta. Correct? So now I can simply write this as 2 into 6 divided by 4 equals to 1 over cos cube 2 theta. Now I can write this as cos cube 2 theta, which is equal to 4 divided by 2 into 6. Cross multiplication. So I can write this as cos cube 2 theta, which is equal to 4 over 12. Correct? So I get my cos cube 2 theta as 1 over 3. So basically now, okay, I get my cos 2 theta as the cube root, okay, because of the cube root of 1 over 3. Now I need my cos to be positive. Correct? My cos is positive in my ASTC curve. It's positive in the first quadrant and the last quadrant. The first quadrant is theta, the last quadrant is basically 2 pi minus theta. So here I can simply do 2 theta, which is equal to, on the calci in the radian mode, first do the cos inverse of the cube root of 1 over 3, which is 0.80465, comma, now do 2 pi minus 0.80465. So you simply get 5.4785. Now you can simply divide 2 by each of this value. Correct? So I basically get 0.4023, comma 2.739. Correct? But now I know I can only get one value of theta. So if you see in the question here, they have specified a domain for theta between 0 to 1 over 4 pi. But here if you see, 2.739 is exceeding the domain. So the only value for theta to 3 significant figures is basically 0.402. Correct? This is what I basically have. And this is the final answer. So with this we come to the end of the chapter of parametric equations. Now after this we'll have the small capsule where we'll revise some AS level terminology which they use, okay, in questions, which is really important and will be, these terms are used in almost every past paper question related to differentiation. So please view the next video to complete this chapter. Thank you very much for watching.